Have you ever wondered how the seemingly simple and common substance known as cement is made? This unassuming material has an extraordinary role in shaping our world, quite literally. Cement is the foundation of our cities, the skeleton of our infrastructure, and the backbone of our buildings. It's so deeply woven into the fabric of our lives that we barely give it a second thought. Yet the process of making this ubiquitous material is a fascinating journey of transformation. From humble raw materials extracted from the earth through a series of complex processes, we get this sturdy and reliable substance that is cement. It's not just about mixing water and powder, it's a science, an art, and a testament to human ingenuity. So are you ready to embark on this journey of discovery? Today we shall unravel the step-by-step process of how cement is made. The first step in the cement-making process involves the extraction of raw materials. So what are these raw materials we're talking about? Predominantly we're looking at limestone and clay, but there's also silica, alumina, and iron ore in the mix. These components, when combined in the right proportions, will give us the cement that we use every day. Limestone, the main ingredient, provides the calcium necessary for cement production. It's a sedimentary rock composed mostly of skeletal fragments of marine organisms such as coral and shells. Clay, on the other hand, is a fine-grained natural rock or soil material that combines one or more clay minerals with traces of metal oxides and organic matter. It brings the silica and alumina to the table. Now, let's talk about how we get these raw materials. As you might have guessed, it's not as simple as picking up a shovel and starting to dig. Large-scale operations are required to extract these materials from the earth. The extraction process usually involves drilling or blasting to create an open pit or open-cast mine. Once the raw materials are exposed, they are then transported to the processing plant. The limestone is usually extracted from open-cast quarries, where it's blasted out of the ground in large blocks. These blocks are then crushed into a manageable size before being transported to the processing plant. The clay, which is typically found in layered deposits, is excavated using heavy machinery. It's a meticulous process that ensures the right amount of each material is gathered. Extraction methods can vary depending on the nature of the deposit and the material. For example, silica, alumina, and iron ore are typically obtained from their respective ores through a series of chemical reactions. Once these raw materials are extracted, they are ready to be processed. But that's a story for the next scene. Stay tuned as the journey of cement making continues. The next step involves crushing and mixing the raw materials. Now this is where things get particularly interesting. The raw materials, once extracted, are not immediately suitable for cement production. They need a bit of a makeover. First, they go through a process of crushing. Picture this. Large industrial machines bearing down on the raw materials, breaking them down into a much finer powder. This isn't just a quick touch-up, it's a complete transformation. The raw materials are pulverized until they're almost unrecognizable, but crushing is only half the story. Now imagine the finest powder you've ever seen. That's what these raw materials become. But we're not making face powder here, we're making cement. So the next step is to mix these finely crushed materials together. In a large rotating drum, the powdered limestone and clay are combined to create what we call a raw mix. This mix is carefully balanced to ensure the right proportions of each material. It's like baking a cake. Too much flour and it's dry, not enough and it's gooey. The same principle applies here. The right balance is crucial to achieving the perfect cement mix. The crushing and mixing processes are not just physical transformations. They're also a crucial part of reducing carbon emissions. By crushing the materials into a fine powder, we increase the surface area for chemical reactions to take place, which in turn reduces the energy required for heating later on. And with sustainable materials like partana, we're not just making cement, we're making a difference. After the crushing and mixing, we are ready to heat things up. So let's turn up the heat and move on to the next stage of cement production. Now it's time to turn up the heat. This stage of the process involves heating the mixture in a device known as a rotary kiln. Picture a large cylindrical furnace rotating on an inclined axis. It's in this fiery furnace where the real magic happens. The raw mix, now known as kiln feed, enters the high end of the kiln, while fuel, typically coal, oil, or natural gas, is injected into the lower end. As the kiln rotates, the kiln feed moves gradually towards the lower end. The intense heat causes a series of chemical reactions that transform the kiln feed into something called clinker. So, what are these chemical reactions? Well, there are three main ones to be aware of, all occurring at different temperatures. First, around 800 degrees Celsius, the limestone starts to decompose and release carbon dioxide. Next, at about 1500 degrees Celsius, silica, alumina, and ferric oxide react to form a compound known as C3S. Finally, around 1300 degrees Celsius, the remaining calcium oxide reacts with the other materials to form C2SE. These C3S and C2Se compounds are what give cement its strength. After the clinker is formed, it's time to cool things down. The clinker is then rapidly cooled with air in a process known as quenching. This abrupt cooling helps stabilize the clinker and halt the chemical reactions. The cooler the clinker, the easier it is to grind and the better the cement will perform. So we've taken our raw materials, crushed them, mixed them, heated them up and cooled them down, but we're not done yet. The next step is to grind the clinker into a fine powder, but we'll save that for the next scene. With the heating and cooling done, we are now one step closer to our final product. The final step is grinding. This phrase may seem simple, but in the world of cement production it carries a significant weight. It's the moment of truth, where all the hard work put into extracting, crushing, mixing, heating and cooling the raw materials culminates in the creation of the final product, cement. So what exactly happens during this final step? Once the clinker has been cooled, it's combined with a touch of gypsum. Gypsum, a soft sulfate mineral, is the secret ingredient that controls the setting time of cement. Without it, cement would harden too quickly, making it impractical to use. The cooled clinker and gypsum are then introduced to a grinding mill. This powerful machine works tirelessly, reducing the clinker and gypsum into a fine powder. The grinding process is meticulous and precise, ensuring the resulting cement has just the right consistency. It's a bit like baking a cake, too coarse or too fine, and it just won't turn out right. As the mill grinds away, it's creating something truly remarkable. This fine powder, seemingly simple and unassuming, is in fact an essential building block of modern society. It's the stuff that binds our buildings, roads, bridges, and more. The humble cement created through this grinding process powers the construction of the world around us. And there you have it, the creation of cement from raw materials to the final product. Cement making is a complex process, but every step from extraction to grinding is crucial in creating this indispensable material. So the next time you see a skyscraper or drive over a bridge, remember the grinding mill and the pivotal role it plays in bringing our built environment to life. Let's recap the journey we've taken today. We've delved into the intricate world of cement making, a process that begins with the extraction of raw materials. Limestone and clay are meticulously mined from quarries, creating the fundamental building blocks of cement. Next, we've seen how these raw materials are crushed and mixed together. This stage is crucial as it ensures the right balance of components, which significantly influences the quality of the final product. The mixture is then subjected to high temperatures in a kiln, creating a chemical transformation that results in what we call clinker. The cooling phase that follows is equally significant as it stabilizes the clinker, preparing it for the final stage of the process. And finally, we've learned how this clinker is ground into a fine powder, creating the cement that is used in construction projects all around the world. Each step in this process is vital, and each carries its own set of complexities. From the careful extraction of raw materials to the precise temperatures needed for heating and cooling, the journey of cement making is a testament to human ingenuity and the relentless pursuit of progress. In recent times, the cement industry has been finding innovative ways to reduce its carbon footprint, such as the development of carbon capture technology. This is an important step forward in making the industry more sustainable and contributing to the global fight against climate change. So, the next time you see a building, remember the intricate process that goes into creating the cement that holds it together. Thank you for joining us on this journey into the world of cement making.